Okay, here's a how-to video on the triangle sum conjecture and the third angle conjecture. For the triangle sum conjecture, you first need to start by constructing a triangle using the polygon tool. Choose the last one here, and you're just going to connect three sides to make a triangle. What you're trying to show here is the sum of the three interior angles of a triangle add up to 360. So what you want to do is go ahead and mark all three interior angles. You can then click on those markers, choose measure angles, and you have the measurement for the three angles. Then you want to show the sum is equal to 180 degrees, so you go to number, calculate, and using the calculator you choose one at a time, and you're going to add those together. And that's it. So that is how you make the sketch for the triangle sum conjecture. No matter how this is moved here, you'll notice that the sum always equals 180 degrees. The second one I want to show you was a third angle conjecture here. So what do we want to show here? We want to show two similar triangles. So I'm going to start by making one triangle, and then I have to make another similar triangle. So how I'm going to do that is I'm going to choose a point not on the triangle, or construct a point not on the triangle. I'm going to mark this as a center for dilation. So I'm going to double click it, or you can right click and select mark center. You are then going to highlight the triangle, and you want to transform dilate. Okay, I'm going to leave the fixed ratio at 1/2, but you can change it to 1/4, or you can enlarge it, say 2:1 or 3:1 or what have you. We're going to dilate it, and essentially you can see as you move this point that this is each of these points. So if you were to take this point in comparison to the point that we created as a center of transformation, this distance is halfway between those 2 points. Just like the distance halfway between these 2 points here is this guy, and then the distance from here to here cut in half would be this one. Okay, so what do I want to show here? I want to show that if two of these angles are the same, okay, so I'm going to measure all four of these angles. Measure angles. So we're going to show that that angle there, let's see if I can move some of this stuff over here. Okay, so angle C and angle C prime have the same. Let's see if I can shrink these here. So angle C, C prime, and then we have angle B and angle B prime. You can see that no matter how the triangle is moved, that those will stay congruent. In fact, why don't I double strike those so that you can see how they line up. So basically what this conjecture is saying is if you have two angles in one triangle congruent to two angles in another triangle, what do you know about the third angle? And so if we were to measure that third angle, we're going to find that when we measure these angles, that their measurements are congruent. Okay, so when you have two angles in one triangle congruent to two angles in another, their third angles must be congruent.